Welcome to October's Leetcode Challenge. Today's problem is remove covered intervals. Given a list of intervals, remove all intervals that are covered by another interval in the list. Interval AB is covered by interval CD if and only if C is less or equal to A and B is less or equal to D. After doing so, return the number of remaining intervals. So this problem is very similar to the merge intervals problems that we've seen before. Let's think about what sort of possibilities we can get ourselves into. And the very first thing that we generally do with these sorts of problems is to try to sort our intervals, right? And we want to sort it by the starting position, and that's going to give us a big advantage in terms of how we could generate our new output to figure out which intervals are covered, and if they're covered, we can just get rid of those. So if we have sorted this, there's a couple of possibilities that could happen, right? We could have a completely non-overlapping interval like this. The start position of the next interval is greater than the end position of the last one. If that's the case, we just insert this next interval, right? There's nothing to it. But there's a couple of other possibilities that can happen though. What if the start position of the new interval is less than the end interval of the previous one? And if that's the case, there's a couple things that can happen, right? It could either look something like that. It could be completely engulfed like this. The next one could just be something like this. Or it could actually, because of the way we sort it, the start position is the same as the previous start position, but the end position is actually greater, right? So these are three possibilities that can happen if they're not covered, but they're overlapping. So which ones are actually covered here? Well, this one's clearly covered, right? This second interval is covered by the first interval. But what about this one? We can see that second interval covers the first one, right? This one is not covered. It is overlapping, but technically it doesn't completely engulf each other. So we'll just add that into our next output. And at the very end, what we're going to do is just return the length of our output. Here, whenever we find these cases to be true, that the start position of the next interval is equal to the start position of the last one, then we can just update the previous interval with the max of either one. It's either going to be equal or greater, right? So we'll just update that and get rid of that interval. Or if it looks like this, we'll just not insert it and we'll just move on to the next one. Like, I guess we can just update with whatever the maximum is between this one and this one. It's always going to be the first one, but in our algorithm, we can just say it like that. All right, so knowing that, we have our four scenarios, right? So very first thing we want to do is, if not intervals, we're going to return 0, and we will sort our intervals. And this will default to sorting it by the very first position, and then the second position, and so forth. It's just going to be 2 here with the start and end. So the very first thing I'm going to do is initialize an output. And this is what we're going to build our other intervals with. And we'll decide whether to insert the next interval or to update the previous one. So for start and end in intervals, and we can start with the second item inside of our list. And what are we going to do? Well, the very first thing is if they're not overlapping at all, if the start is greater than our output's very last index or very last list, the second position, the end, if it's greater, they're non-overlapping, so just append a list of start and end to our output. Otherwise, we have those three scenarios we talked about, right? And it could either be completely engulfed, either way, or they might be overlapping, but they're not engulfed, so we're going to add that output. So what scenarios could happen if they're engulfed? Well, the first thing is maybe the end is less than the output's last interval end position. So if it's less or equal to, either way, if this is the case, then they're covered, right? Because we know the start is less or equal to the previous output ones. I should say, yeah. So the start is not greater than the end of this previous one, but this end, if it's less or equal to the output of the previous list of this output, then that means it's covered. So that would mean we shouldn't append a new one. Or if the start is equal to the previous interval's start, because of the way that we sorted it, that means this end is either going to be equal to or greater than the previous interval's end. So knowing that, I guess what we can do is just take the previous one's end, and we're just going to update that to the max of either this or the end that we're given. But either way, we're not going to append a new start and end list because these conditions mean that they are covered. Otherwise, we'll still append it because they might be overlapping, but they're not covered. So once we finished there, we can just return our output, or I should say the length of the output rather. And let's make sure this works. List index out of range. Ah, right. I very forgot. The very first thing we should do is append the first interval right here. And obviously we didn't have any there, so that's why that messed up. All right, so let's try that again. Okay, looks like it's working. Let's try to print that or submit that and accept it. There we go. So this is an O of n time complexity. It's not bad. It's not the best solution possible. One of the things you might see is we have to use O of n memory, but we could use less. We don't really need to keep building this list. All we need to know is the very previous list, right? So if that's the case, I suppose one of the things we can do is rather than appending it, we could just equal the output like this. And what we'll do is we'll store some result, start with 1. Instead of appending, we're just going to update our output to this list here. And whenever we do that, we will increase our result by 1. Same thing here. Say update our output by the new list and increase our result by 1. Here, we're not going to be doing that, right? In fact, I don't even know if I need to do it like this. Output 0 is a list, so we can just say output 1, 1, or E. And finally, just return the result. Hope I did that right. Okay, let's see here. So 1. And doing this would save memory, but it wouldn't really save any time complexity. But either way, there we go. So that's accepted. So I don't love this logic here, but it does get accepted. Luckily with these interval problems, there's not that many scenarios once you sort our list. Not that many edge cases that could happen. So once you kind of figure out what possibilities are there, then just need to write an algorithm for it. So, all right, thanks for watching my channel. And remember, do not trust me, I know nothing.